Hello friends, today I will discuss the economics of power generation. In this topic, I will discuss the necessity of power generation, definition of the economics of power generation, load duration curve, average load, connected load, load factor, demand factor, diversity factor, plant capacity factor, plant use factor, and their related numerical problems. First, what is the necessity of the economics of power generation? For modern society, thinking life without power, electrical power, is unimaginable. So, to run daily equipment at home or industry, we need electrical power. But that power generation involves the lot of capital, lot of employees, rules, loans, losses, etc. Coming to the definition of the economics of power generation, it's basically involves with the deciding the or determining the cost of electrical energy per kilowatt hour is called the economics of power generation. Coming to the load duration curve, it is nothing but a graph between power versus time in hours for a day or a month or a year. If the load duration curve is for 24 hours, then it is called the daily load curve. If it is drawn for a month, it is called monthly load curve. If the load curve is drawn for a year, then it is called the annual load curve. When the load curve is drawn for a day, it appears something like this. At a different time of the day, the consumption of the power or the energy is different. At 2 o'clock, this is the load consumed by the consumers, whereas at 4 o'clock, it is something like this. At 8 o'clock, it is something like this. Again, at the end of the day, it is like this. It is observed here that the curve is up and downs. So it moves like this, then reaches maximum, then reaches here, then goes to this value, then reduces, then reaches the maximum value. Again, it follows the different pattern like this. And in this curve, the y-axis represents the power in megawatts, whereas x-axis represents the number of hours in a day, that is 24 hours. So for each hour, it can be observed that what is the power consumed by the consumer. And in this load curve, this point is said to be peak load, whereas this line indicates the average load on the plant, and whereas this indicates base load. So base load is normally made by the thermal power station, whereas peak loads are made by gas power stations, hydroelectric stations, non-conventional energy sources, And coming to the connected load, it is nothing but the sum of the continuous ratings of all the equipment of the consumers. Suppose this is the power station or substation distributor connected to the consumers, means main services like this C1, C2, C3, C4, C5. These C1, C2, C3, C4, C5, they are the consumers. So this consumer may be a house or a office, and these offices or consumer will have the different loads like fans, ACs, lights, mixes, etc. These consumers will use those loads at different times. Sometimes they use maximum, sometimes they use minimum, sometimes no load. And each equipment, whatever the consumer uses, will have the ratings on them. Suppose fan, its rating is 65 watts. So suppose it is iron, then its rating is 1200 watts. So similarly, other equipment will have the ratings. So for a given consumer, if all the ratings of the equipment are added together, then that is called the sum of the continuous ratings of all the equipment of the that individual consumers. If add all the continuous ratings of all the consumers, then it is called the connected load to the power station. Coming to the average load, it can be defined as average load is equal to the number of units generated in a day divided by the number of hours in a day. So this number of units generated can be seen by knowing the area under this curve. On y-axis load in megawatts, whereas on x-axis time in hours. If this power is multiplied by with the time, then the area of this curve comes. That area is called the energy generated during this period 24 hours. So that energy, I mean the area of this curve divided by the number of hours, that is 24 hours, will give the daily average load. Similarly, maximum demand, it is nothing but the maximum demand of load on the power station during a given period, and that can be defined like this: load factor is equal to average load divided by maximum demand. So maximum demand means nothing but this peak load. Average load means this. Similarly, demand factor, that is nothing but maximum demand divided by connected load. Similarly, there is another term called diversity factor. It is nothing but sum of individual maximum demand divided by maximum demand on power station. If the load curve is drawn with respect to a month, that is called monthly load duration curve, then in that case monthly average load can be calculated as number of units generated in a month divided by number of hours in a month. Similarly, annual average load or yearly and average load, This is also the ratio of number of units generated in a year divided by number of hours in a year. Similarly, another factor called plant capacity factor. It is nothing but the ratio of actual energy produced divided by maximum energy that could have generated. That is, it can also be written like this: average demand into time divided by plant capacity into time. That also can be written like this: average demand divided by plant capacity. Coming to the plant use factor, it is nothing but station output in kilowatt hours divided by plant capacity into number of hours of use of the plant is given by plant use factor.